Hello, in this video I am going to solve two more examples related to my lecture about arc length that I published 2 days back. I think we need more examples in that regard to be able to understand what was going on in that video. So let us see what example I'm going to solve today. So the first one, example 1, find the length of the curve for y equals to 2 ln of x minus x squared from x equals to 1 to x equals to e. And this is just a reminder of what we had in the previous lecture. So the formula that we are supposed to use is L equals to integral from a to b square root of 1 plus f prime of x squared dx. So now let us go to the board and start solving the first example. Okay, so here I have to calculate L, which is integral from a to b. A in this problem is 1, b is e, square root of 1 plus y prime squared, which is the same as f prime squared dx. So the first thing that I have to do is to calculate y prime. So what is y prime? I have to divide everything by 2 first, so y becomes 1 half ln of x minus 1 over 4x squared. Then I differentiate both sides, so y becomes 1 half is a constant. The derivative of ln of x is 1 over x, so it becomes 1 over 2x. And then here, 2 goes down, so it becomes minus a half x. So this is the derivative. Okay? And now I have to calculate this combination. So 1 plus y prime squared. So this becomes 1 plus 1 over 2x minus 1 over 2x squared. But then it becomes 1 plus this 1 squared is 1 over 4x squared minus 2 times the first one times the second one, which will give me minus a half, yes? Plus the second one squared, which is 1 over 4x squared. Okay? So remember, this expression is the answer to this problem, but now something interesting happens. This 1 and minus 1 half becomes 1 over 4x squared plus 1 half plus 1 over 4x squared. Now if you compare this one with this one, you immediately realize that is also the expansion of a complete square. What that is, the same expression, but the difference is that you have plus in between, yes? So this becomes 1 over 2x plus 1 over 2x. Okay? So if you raise it to power 2, this will give you this. 2 times the first one times the second one with plus sign will give you this, and the second one squared. That is crucial, because now you know that in the formula I have a square root, and this square root will cancel that is power of 2. So L, which is my question mark, is integral from 1 to e, square root of this expression. Square root of that expression is the absolute value of this dx. But I do not need the absolute value here at all, because x is somewhere between 1 and e is also 2.7 approximately, so x is definitely positive. If x is positive, this is positive, this is positive, I really do not need the absolute value sign, so I can take it off and just put a normal pair of brackets around it. And these are very simple integrals to calculate. 1 over 2 is a constant, but a primitive function of 1 over x is just ln of absolute value of x. 1 over 2 is a constant. A primitive function for x is 1 half x squared. But I have to run everything from the lower limit 1 to the higher limit e, upper limit e, yes? Okay, so what happens? I replace every x with the upper limit. So it will give me 1 over 2 ln of absolute value of e plus 1 over 4 e squared. And then I replace every x with 1. So this becomes 1 over 2 ln of absolute value of 1 plus 1 over 4. So, but absolute value of e is e, ln of e is 1, so the answer becomes 1 over 2 plus a quarter of e squared. ln of absolute value 1 is 1, ln of 1 is 0, so this is gone, so it becomes 1 over 4. And then I have to subtract these two numbers, so 1 over 2 plus 1 over 4 e squared minus 1 over 4. So this becomes positive 1 over 4. So it becomes e squared plus 1 over 4 length units. So this is the answer to this problem. Okay? Now, I will go to the second example. In the second example, find the length of this curve, ln of cosine of x. X goes from pi over 6 to pi over 4. I will use the same formula, but for this function. Let us do it on the board. Okay, so again, the same story. The first thing I have to calculate is y prime. So y prime, ln of cosine, the derivative of ln of a function is the derivative of that function, which is minus sine, divided by the same function. Yes, it becomes cosine. But that is just simply minus tangent of x. So that's the derivative. But what combination I need? I need this combination, square root of 1 plus y prime squared. You see that in the formula, I have that. Yes? Square root of 1 plus y prime squared, I need it. So it becomes square root of 1 plus that expression is squared, tangent x squared. But that is a very famous combination in trigonometry. This is secant x squared. So this becomes a square root of secant x squared, which becomes absolute value of secant of x. But do I need absolute value here? For the same reason in the problem, in the previous problem, no. Why? Because x goes from pi over 6 to pi over 4. It means that x is in the first quadrant. And secant is just 1 over cosine. In the first quadrant, cosine is positive, so secant is also positive. So the answer, the length becomes integral from pi over 6 to pi over 4. And then instead of putting absolute value of secant, I just simply put secant x dx. But that is also a famous integral. I hope that you have seen this in your calculus courses. So the primitive function for ln of secant is ln of absolute value of secant of x plus tangent of x. Okay? And then you have to run it from pi over 6 to pi over 4. And then I put it here, so this becomes ln of absolute value of secant of pi over 4 plus tangent of pi over 4. And then I have ln of secant of pi over 6 plus tangent of pi over 6. Okay? But you know that secant is 1 over cosine x. We don't need absolute value here, as I told you. So secant of pi over 4 is 1 over cosine pi over 4, which becomes square root of 2. So this becomes ln of square root of 2. Tangent of pi over 4 is 1, and because it is positive, I don't need absolute value sign. I replace it by just normal pair of brackets, and this one becomes ln. Pi over 6 is 30 degrees. Cosine of 30 degrees is square root of 3 over 2, but this becomes 2 over square root of 3 because that is the reciprocal of cosine, and tangent of pi over 6 is 1 over square root of 3. Yes, but this can be written a little bit simpler because 2 plus 1 becomes 3 over square root of 3, but 3 over square root of 3 is just simply square root of 3. Yes, and then the answer to the problem will be the difference between these values. So this becomes ln of square root of 2 plus 1 minus ln of square root of 3. If you want, you can keep it like this, of course, but if you want, you can combine these two ln's to write ln of 2 square root of 2 plus 1 divided by square root of 3. I myself prefer to rationalize the denominator by multiplying both numerator and denominator by square root of 3. So this becomes square root of ln of a square root of 6 plus a square root of 3. The denominator simply becomes 3 length units. So that will be the answer to this example. Now I hope that more or less you have more experience in solving the problems about the arc length. I will of course make some videos for problems which on the same topic which are a little bit more challenging. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.